In this video, we're going to look at another large data set and consider how to look for differences between more than two groups, and this will take us towards undertaking an analysis of variance statistical test. And the type of test I'd like to do first of all just looks at one factor. And just to remind you, as in my little purple note here, an ANOVA, unless it's a variance, if it's just looking at one factor, what we're looking at is more than two groups and just one factor, so just one thing that varies between the groups. And with all our statistical tests, we can undertake this by using the data analysis add-in in the data tab. So this is our data set that relates to complaints in the National Health Service. And I thought that what we would try here is to look at differences in the number of complaints in different ages, different age groups within one regional characteristic and one time period. So I'm keeping certain things the same, but I'm looking at the differences in the age. So we've got here, for example, in column M, age 0 to 5, N 6 to 17, and then 18 to 25 here. So those are the three columns that I'm particularly interested in here. And of course, I could actually therefore hide quite a lot of the other columns if I wanted to. So I'm interested in looking at the differences in those three groups in the north of England. And just to remind you, that's if I go to this column over here, this relates to rows 2 down to 53. I think it is. Whoops. There we go. And I'm only interested in the first quarter. So although the north of England will come up later on in the data set again, that's in relation to quarters 2, 3, 4, etc. So we're just interested in those rows there. Okay, so if I go back to my columns of interest over here, and I could highlight them actually, that would make them show up a bit better so I know what I'm looking at. So go to the data tab, go to data analysis, and remember that you need to add this in if it isn't already showing up in your version of Excel. And then in the dialog box that comes up, we need an ANOVA single factor. Okay. It wants to know an input now, input range. And I can, in this particular case, because the column headings are directly above the data, I can use them as well. And so what I need to do now is to go down to row 53. That's where my information from the north of England comes to an end. I think that's right. So that's grouped by columns, meaning to say that the three different groups are in columns. We do have labels in the first row, so I can take that. As usual, we have alpha as 0.05, meaning that this is the value of the probability below which we reject the null hypothesis, above which we accept. Because this worksheet is so very busy, we won't put our output on this page. We'll have a new worksheet and we'll click OK. So the output we have here then shows us various things that have happened. It shows us how many individuals we've had in each group. It shows that there's been a calculation of a statistic called an F statistic. We're not particularly interested in that. The thing that we're really wanting to look at is the p-value. And if you remember, if it's above 0.05, we accept the null hypothesis and say that there is no significant difference between the groups. And that's what it looks like here. This value of 0.22 is higher than 0.05. And in fact, if you look at the average value of complaints, it's pretty low. It's not that dissimilar, I suppose, really, between the three categories. So just to go back and remind us of the test that we've just done.